7.8, factoring completely. So we will use our factoring, well, actually we'll be using our distributive property to help us factor more complicated problems, but it's really the distributive property in a more complex way. So for example, number one, we'll start with x to the third power plus 3x squared plus 2x plus 6. Now, at first look, it doesn't look like, well, it's in standard form where the x's are in descending order, but it looks like it doesn't factor. But if we add some parentheses here and look at, well, if I can kind of group these into more of a group, two groups, I can see that these two both have a common, the first group has a common factor of a GCF or GCMF or monomial factor, has a common factor of x squared. And we notice over here on the last one, this one has a GCF of 3. So what we can do is factor out that x squared out front, and we're left with x, because x squared times x is x cubed, plus x squared times 3 is 3x squared. Now, if we bring down the plus, we'll factor out not a 3. What was I thinking? I'm thinking a 2, and 3 is in my head for this last term, so this should be a 2 as a common factor. So 2, I always kind of do that. I think about the other one that I'm factoring out. So 2 divided out of 2x would be x left over, and 2 divided out of 6 would be 3, or you can think of it as 2 times x is 2x, and 2 times 3 is 6. So now you notice that there's a x plus 3 and an x plus 3. So now we do another distributive property, and we distribute out that group of x plus 3 all the way out front. So we're going to distribute out that x plus 3 first. So we'll pull that all the way out front, and then we'll be left with x squared plus 2. And I know that because I'll factor out that x plus 3, we could distribute it back in, and we'd have that times, and then x plus 3 distributed back in times 2 would be this other fat group of multipliers. So when we have these two factors, we've factored it completely. It didn't look like at first that we had a common factor of x plus 3, but there is. Now I'm going to look at the x squared plus 2 and think, can I factor that also down here? And I'm thinking in my head, well, I could bring down that x plus 3, but then I'm thinking, I'll have an x and an x, but I'll need to multiply a positive number and a positive number over here, and the only common factor would be 2, 1 times 2. So, and that would make a middle term of positive 3. So even if I switch the 1 and the 2, it wouldn't work. So that right there is our factored form. So we will circle that factored form for our first example. Now on to our next example, where it gets a little bit more complicated. X cubed minus 9x plus 27 minus 3x squared. All right, so things are a little bit jumbled up, which is okay, but I noticed here, and I'm thinking in my grouping, is I can have a common factor here and here, and I kind of almost see something like that 9 over here, but it's probably with the 27. So what I'm going to do is I'm going to put those in a parentheses, and I'm going to rearrange them, kind of using my commutative property of addition to rearrange them. So I'll rewrite it. So 3x, 3 cubed minus 9x plus negative 3x squared plus 27. Now, some people will reorganize it and put that minus out front, but I'm really cautious about that because when we distribute out, we have to be very careful about that negative. And that's where a lot of people make their error. And I'll show you that after the second time. So I like kind of this organization for myself. So this one has a common GCF of x. This one would have a GCF. Well, normally we would put a 3. And that would be the easiest one to take out. But remember, notice this negative here. Right here, there's a minus. And I know I don't have a minus here, but I have it out front. So what I'm going to do is distribute out a negative. So that will make my front term positive and my last term over here negative, which will kind of match that other term there. So now I'm going to factor out, or that I have an x squared. So factor out that x. So x squared minus 9, because I distributed out 8x, so x times negative 9 is negative 9x. Minus 3 is my GCF for my second group of distributive properties. So if I distribute out a negative, I'll be left with that x squared, which kind of matches this other one. And then a negative, because a negative times a negative is a positive 9. And now I can take and distribute out that group, the whole group of x squared minus 9. So I will distribute out that out front, x squared minus 9. And what I'm left with inside is our x minus 3 here. And that's those multipliers, because I can think of this being multiplied, the whole group being multiplied by x to get this first multiplying group, and distributing it to the minus 3 to get that second group. So now you would think that I'd be ready to circle it like this up at the first one, but it's not, because you can see that first term actually it's a difference of perfect squares. So I can factor that as x and x plus 3 and minus 3, because that middle term will zero out, and I have a negative 9 as my constant, and I have an x squared as that front term. And then don't forget to bring down our x minus 3 over here. Hey, looky there. There are 2 x minus 3's. So I'm going to reorganize this and rewrite it to simpler terms. X minus 3 squared, because there's 2 of them, and then x plus 3 as the simplest form for writing that factored form. And that looks a lot nicer organization-wise. All right, another example of this, number 3, would be x squared plus y plus x plus xy. So I'm thinking, things don't work too well to begin with. So what I'm going to do is reorganize it, and I'm going to put my x's together. So it's kind of like a little game. You kind of like try things. If it doesn't work, then try something different. Oh, I'm going to move my x, y first, plus y. And the reason why is because I noticed when I had my x squared and my x together, I'll have leftover x's up front. So I kind of want this xy out, because I'm going to take that y out, distribute out that y, and have an x left over in the front. So I'll put in my grouping symbols, and I'll just GCF of x and a GCF over here of y. And I don't have to deal with a negative, which is kind of nice. So x times x plus 1, because x times x is x squared, and x times 1 is x, plus y, because that's a positive y, and then y times x is xy, and y times 1 is y. So now I've got my group that I'm going to distribute out of x plus 1 out front. So I'll distribute that x plus 1 out of our groups, and I'm left with x, because x plus 1 times x is x times x plus 1, plus y, because x plus 1 times y is the second grouping multiplying, and hey, there is my factored form for that problem. Now, number 4, we get into a little bit more different factoring completely. So we have 3x to the third minus 18x squared plus 24x for this one. Now notice the other ones all had 4 terms. This has 3. So I'm thinking, oh, I'll do my GCF to start with. So my GCF that I distribute out will be 3x, because they all have a 3 and they all have an x. My first term is positive, so I like that to stay positive. So 3x is my distributed out, my GCF. So 3 times what is 3? Oh, so 3 times 1 and x times x squared is 3x squared. 3 times, this will have to be a negative to be a negative. 3 times 6 is 18. 3 and x times x is x squared. Positive, so 3 times 8 is 24. And x times is 1. X times 1 is x, so it's just in the x. So now that I've got my GCF, I'm going to see if I can factor this piece. So x and x, I know my middle term's negative, my end term is positive, so it has to be a minus minus, and my factor pairs are 1 times 8 and 2, there it is, 2 times 4, because when I add those together I get 6. So that'll be a 2 and a 4. So I'll double check that. Negative 2x and negative 4x is negative 6x. So these would all be negatives. All right. Oh, and there is my factored form. So that's using our GCF. And our next example will use that same idea when it's just a little bit more complex. So 7x to the fourth minus 28x squared. Ooh. So I have my GCF of 7x squared. So I'm thinking about it as, and this will have to be a minus. 7 times 1 is 7. X squared times x squared is x to the fourth. 7 times 4 is 28, and x squared times 1 is x squared. Oh, do you notice something about this factored? So I'm not done factoring. If I left it there like this, I would not be completely factored. I'd have factored one term out, or one factor, but I need to factor completely. So I notice that this is a it's a perfect positive and negative. And so x minus, and then 2 times 2 is that 4, and there's a 1 negative, so it's a negative, and that middle term zeroes out. So we multiply our two factors that are opposites. And that is our factored completely. So now how do we do this so that we can solve equations? So number 6 will be solving equations. So we have, oh, I forgot one other problem before this we have to talk about. And if we have, before we solve problems, p squared plus 4p plus, minus 2. All right, so what I'm going to do is I'm going to think about how am I going to factor this. P times p, I have a minus for my c, so that means 1 plus and 1 minus. My factor pairs are 1 times 2. So that would be a 1 times 2 here, but my middle term would be a negative 2, so that would be a negative 1p as a middle term, and I have a positive 4. So if I take and switch those and move my 2 and my 1 here, all that does is move my negative, which would be a positive 1x as a middle term, but I need that. So there is no nice integer numbers that we could use for these. So this is what we call, it is not factorable, and it is what we call it is prime. So just like our prime numbers, there's no factors that we can use. So we would write that on our line as in factored form, because we can't factor it any further, and I would just name it as prime. Now we have to watch out because there are some problems that we think are prime but are factorable. We have to test all the factor pairs. So this one's a nice one because it's a prime number back here for C, so our list of prime factor pairs, or factor pairs that work together to get our middle term, is very short. But we might have a bunch of them, like if we had 28 or 48, we'd have a lot of factor pairs that go in here. And so you'd have to test each one of those to make sure it doesn't make that middle term. Because if you miss one and you think it's prime and it is factorable, you have not factored that number. And so you would lose quite a few points if you did that on a test or quiz. All right, so now on to our solving. All right, so if we have 2x cubed plus 8x squared equals 10x. So remember, we want to use our zero property product. So we're going to make one side, this side is the easiest, to be 0. That's our first goal, is to get one side equal to 0 before we do anything else, because then we can use our zero product property. If we have something over there, we can't solve it with the zero product property. It has to be 0 over there. So now I see I have a common GCF of 2x. So I'll factor that 2x out first and bring down my equals 0. So let's see, 2 times 2 is 1. So that'll be a 1. X times x squared, which I like, is x cubed. 2 times 4 is 8, and x times x is x squared. And 2 times a negative 5 equals negative 10. And x times this negative 5 is negative 10x. So now I remember this one I've done this a couple of times. So x and x, I have a back term of negative, so that's a plus and a minus. 5 is prime, so there's only 2 factors, and I have a positive 4, so I'll make my 5 positive and my 1 negative and double check my middle term. So negative 5 plus negative 1, or positive 5 plus negative 1 is a positive 4. So now I can continue to solve this, and I know that my x has to be 0 over here for this one. So that's one solution. X plus 5 equals 0 is another, and x minus 1 equals 0. I'm using my zero property product to solve this. And x equals negative 5, and x equals 1. So my solutions for this original problem to make that equation true is x equals negative 5, or 0, or 1. And we have 3 solutions for that one. The next problem, number 8, for factoring completely is a little bit trickier. 3t cubed minus 5t squared minus 3t plus 5 equals 0. All right, here we go. So I notice, and it is in standard form, which is nice, and I notice that I have a t squared common factor up here in the first 2 terms. And then this is the part that's tricky because we have this negative here. Now, I notice that I have a minus here with my 5. So when I put my parentheses in, and this is where once I put that parentheses in, that means I distributed out a negative. A lot of people will, when they first start these, they don't think about that. They just distribute it. They just throw a parentheses in. So once I put it here by my 3, that 3 becomes a positive, which it was originally negative. But that means I distribute that negative into the 3t to get a negative 3t, which is the beginning. But I also have to distribute that negative 3 to this second term. So what happens is this becomes negative when I put that parentheses right next to my 3 on the right-hand side of that subtraction. So just be very careful with that. And I like that because it now matches the other negative over here. And I can see that I have a 3t minus 5, and I'm going to have a 3t minus 5 over here. So just be careful with watching out for that negative right there. So we have t squared times 3t minus 5 minus, now this, I know in my next step I'm going to distribute out that 3t minus 5. So I kind of want to put that hidden 1 there so that I have a number to put in my parentheses. All right, so now I'm going to distribute out the group 3t minus 5. So that'll be my distributed out 3t minus 5, and I'll be left with, bring down my equal 0. So if I distribute that to the first term, would be t squared to be my front number or group, and minus 1, if I distribute that to the second one, that would be my second group over here. And this is where a lot of people get stuck right here because they're like, wait, I can solve the first factor, but the second factor, and this is kind of a little trickier one. I don't know if you see it now, but it is factorable. They are both perfect squares. T squared is a perfect square, and 1 is a perfect square. And it is also negative. So I've got a t plus and a t minus, and then I have a 1 and 1, and that middle term will zero out with that 1. So back up here, if we think about it, this is a negative 1 that we have, when we put that parentheses in, it distributed out a negative 1 to begin with. So now I can solve these two. So 3t minus 5 equals 0, t plus 1 equals 0, and t minus 1 equals 0, using the zero property product to solve each of the terms or each of the factors that will make this equation equal 0. So 5/3 is one of them. Minus 1 plus 1, and t equals negative 1 for this plus 1, and t equals positive 1 for this t minus 1 to make that 0. So our solutions on our solution line would be negative 1. Well, we could do plus or minus 1, comma, 5/3. And each one of those will make this problem equal to 0.